row when he was 30 and everyone thought he was too old. This only cares about how many times he won. How many times he won, or how many flowers you got, or how many cards you correctly picked out of the deck is recorded by the row number. So this row refers to getting one flower pot. Yeah? Not whether you got the first, or not whether the last flower came out. It doesn't care where it happened. It only cares whether you got it once. Which means there's actually 10 ways for it to happen. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Yeah? This row here, this row records the probabilities of getting one heart right. Okay? So, what is the probability if you pick 20 cards out of a pack of getting one right? Now, it should be pretty low, shouldn't it? You'd expect to get 5 right, wouldn't you? Wouldn't you? Yeah, because it's a probability of a quarter. I'm always telling people to do that. Always just think what you're going to expect, because it will tell you whether the probability is too high or too low. You'd be expecting 5, right? You would be a pretty unlucky card picker if you only got 1. That's why this figure is so low. The probability of getting 1 right, whether it's your first pick, your last pick, or your middle pick, or your one after the middle pick, is only 2.5%-ish. Okay? So that's what the table is. It's just a whole bunch of probability answers for a whole bunch of situations where somebody was doing something repetitively. Is everyone cool with that?
Yeah. I'm a little bit confused about the row. Like,
yep.
What do you mean by it being right? Like, the number of flower pots that were right?
I should have said that flowered.
But isn't that the probability?
Okay, so let's say your flowers have a 20% chance of flowering.
Yeah.
How many would you expect if you plant 10? 2? Okay, I'm now going to ask, what is the probability of getting 1? Okay? Now, 1 is not that far away from 2, right? So expecting 2 is not a guarantee it's going to happen. So the probability of getting 1 is actually quite likely. The probability of getting 1 is right here for us. It's there. It's about 37%. Okay? Now, is everyone cool? I'm now going to introduce a complication. Okay? I've told you 2 lies in the last 4 minutes. These tables are cumulative. They do not directly tell you the answers you need. They tell you that and lower. In other words, this figure here of 37% does not tell you the result of getting the probability of getting 1 flower pot flowering. It tells you getting the probability of getting 1 or none. This figure here, let's say the flowers are a little better at coming out. Now at a 50% chance of coming out. This figure here tells you the probability of getting 3, 2, 1 or 0. Which is why this table is not very useful. It doesn't actually answer that many questions directly. First of all, there aren't that many columns. 48% is not in this table, because that column is for 45%, that column is for 50%. That's the first problem. Second of all, it stops at 50%. What about a probability of 80%? That's not on the table. Third problem, it doesn't have a box. It goes 5, 6, 7, 8, 9, 10. But what if you have 13 repetitions? There's no box for that. It's a flawed system. And the final flaw is it doesn't even tell you the individual answers you need. It only groups them together. There's one exception to that. You can always rely on this. That is the probability of getting no flowers when you did 10 flower pots with a 50% probability of getting a flower. Okay? So that you can rely on. That is the figure for none or 1. That is the figure for none, 1 or 2. That is the figure for 0, 1, 2, 3, 4, 5, 6, 7, 8. All lumped together. Okay? So if you're thinking that this is a good system, you're crazy. It's got 4 flaws.
Why is the probability for 0.5 the lowest? I don't understand what the numbers actually.
Oh, okay. 0.5.
Like, let's say in the first row.
Yeah.
Why is that one the lowest when it's the highest one?
Oh, because this is where they've got a good chance of flowering. So this is where it's weirdest that none come out.
Oh, so it's like
You're expecting 10. You're doing 10 flower pots, 50% chance of flowering. You're expecting 5.
Yeah.
Getting 0 when you're expecting 5 is way unlucky. That's why that probability is so low. Let's say your flowers are not quite so fertile. They've only got a 5% chance of coming out. That means we're now over here. If you do 10 flower pots and you're only expecting a 5% chance of success, on average, you don't even expect a flower. You expect half a flower. So getting no flowers is not that weird. That's why that figure is so high. These figures are high because 0 successes is not that strange when the probability of success is low. Over here the probability of success is high, it's 50%, here it's 45%. That's why these figures are so low, because getting 0 successes when there's a 50% chance of something happening is weird. Okay? So that is the first part of stats 2. Okay? Now there are solutions to all these problems. There are solutions to the fact that the columns run out at 50. There are solutions to the fact that it jumps from 45 to 50%. There are solutions to the fact that it's got missing boxes, and you can probably guess already right here, right now, there's also a solution to the fact that these are cumulative. Does anyone want to guess what that solution is? It's very simple. You just subtract. Okay? So if that's the figure for 0 and that's the figure for 1 and 0, then the figure for 1 is that minus that. Okay? If you want the figure for 3, 4, 5, that's the figure for 0, 1, 2, 3, 4, 5. That's the figure for 0, 1, 2. So take that one away from that. Take that one away from that one, and you'll get the figure for 3, 4, 5. Okay, so it's a very simple fix. Some of the other fixes are a bit more advanced. Okay, we'll talk about that again next time.